Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're going to see problem minimum array changes to make differences equal. It's going to be a bit long video because as you can see, it's going to be actually a bit long video because of I have to explain width drive and all that stuff. So if you like it, please smash like baby. Because see, these videos don't like not many people watch because not many people actually solve contest while it is being held. So yeah, it will be helpful to connect on Twitter no matter what. Now coming on, let's start off. It simply says that we are given the array nums of size n and n is even, which means we have an even size array. That's one thing. We have also got an integer k. That's one integer which is given to us. Now I can perform some changes on the array. Now what that changes are, I can replace any element in the array with any integer in the range from 0 to k. That is the reason the k is given. So that I can replace this array element inside my integer array to any integer from 0 to k. I can replace. Now why I will replace this? I will replace this such that if I have the array like this, then if I know the array is even, so I can break it down in half. So as I break it down in half, I know that this difference between these elements and these elements, they should be equal. So which means they should be equal to some integer x. That is the reason I can apply the operation of changing any element. And thus ultimately I have to make, again when I say difference, I mean their absolute difference should be equal to x. Such minimum number of operations are required to solve this question. Now the first example which we see right here, we know that we will break it in half and then the difference right here is 2. The difference for this is 4. The difference of this is 1. I want to make all the differences equal. So either I can make all of them as 1, all of them as 4, all of them as 2. That's one thing I can do. Now you might say, Aryan, which means I will try brute force. I will try making all the differences as 1, which means I will go try to make the difference as 1. How to make the difference as 1? Simply, I can change one element. I can change this to 2. Thus, you can see that now the difference has become 1. Same way, I go here, I will change it to 1. Now the difference has become 1. So this thing, I will try for all the differences because I never know which difference could give me minimum number of operations. So what I might end up doing is I might try for all the differences, and I know I have k possible differences because I have elements. That elements itself are less than equal to k. So I know as an element values are less than equal to k. So I know for sure that I can have at max or I can have k differences possible. For every difference, I will have to roughly go and try the entire half array. Because why I say half array, I mean let's say this portion, because anytime I go to I will ultimately also go to n minus 1 minus I element also. So that will be obvious. That is the reason you will take complexity of O of n into k, which will for sure not work because n is 1e5 and k is also 1e5. Now, as soon as it started failing, you might end up feeling, okay, Aryan, in this scenario, it felt like that difference is 1, 4 and 2. So it is obvious I will try for one difference, any difference, and other I will have to change. So it doesn't matter what difference I choose here. Okay, you are saying correct. So what you're doing is you might end up saying, okay, Aryan, I will look at the second example. In this example, I see the difference of this is 4, difference of this is 4, difference of this is 4, difference of this is 0. Now in this scenario, if the difference is 0, so I realize a difference of 4 is coming thrice. Again, I want only pair. I want only pair. That's it. Now the difference of 0 is only coming once. So it makes sense that if I want to, again, I want to make all the differences as equal. So it makes sense, right, to make your difference of 0 as a difference of 4. So that all the differences will now become 4. I already have 3 differences which are 4. One more difference, I can make it equal to 4. Okay, in that scenario, you might say, okay, difference of 0 should become equal to difference of 4, which means that this element, I will try to make the difference of 4 here. Now, currently the difference is 0. I want to make a difference of 4. So, what is the best case scenario? Best case scenario is you don't change anything. Obviously, you will have to change something because your difference is right now 0. Now, you might say, Aryan, I wanted minimum number of changes, which means I will change, let's say, one element only. The best to best case scenario, either you can place it, make it a 0, or you can make it a 6. Although you can change it to any value whatsoever possible, but I am telling you that you have to achieve a difference of 4. But right now, your difference in best to best case scenario, it can be a 6 minus 3, or a 3 minus 0. In best case scenario, your maximum difference possible was actually a 3. Thus, you had to change both the values. Now, he can become a 4, he can become a 0. Again, when I change both the values, I can make it anything. I can make it this 2, this is like this is 6. But the fact is, you realized, oh, if I go by a greedy scenario, which means I found out, okay, this element or this difference is occurring maximum number of times. But the other, the other difference, which is occurring lesser number of times, still it might end up happening is that that specific difference is requiring two changes, which might not be optimal. Why I'm saying not optimal? Because let's take the scenario where you would have two more threes in this. Thus, you will see the difference of 4 is occurring thrice, the difference of 0 is occurring twice. Now, again, by your greedy scenario, you might end up saying, Aryan, I will try to make this difference of 0 as a difference of 4, which means ultimately you are trying two pairs. Now, if I'm trying two pairs, so these two pairs, if I change these two pairs and try to make it a difference of 4, they will give or they will require a cost of 4 because all 4 needs to be changed. But if I have gone vice versa, which means if I have gone and said, okay, I will make these difference of 4 as a difference of 0, which means that, okay, I will, for these, I will make it as 6, I'll make it as 5, I'll make it as 7. Thus, the cost required was 3. That is how you realize, that choosing a lesser count, choosing a difference, having a lesser count might not give you an optimal answer. So a greedy might fail. Now, for few folks who are still believing that they might work with greedy, so they might end up doing is one thing. They might end up saying, okay, Aryan, I realized that I was getting a difference of 0. So I realized one thing, that okay, elements which are close to each other are actually was not able to go to a higher difference value. That is the reason I had to change both of them. Again, you might end up thinking multiple scenarios. I'm telling one such a scenario who are still reluctant on saying, okay, I will still try to find out something here. Then you might end up saying, okay, Aryan, I will try for that. I know that one element will have some kind of a phenomena which will, because if I replace this 0, I might get a cost of 4. If I replace this 4, I might get a cost of 3. So I know this, I was about to replace in the very beginning, but I realized, okay, cost of 4 is more. So I might also try, okay, replace this 0. You might end trying this. Okay, try this. Then look for this example. Again, I'll not explain this example, but look for this example. Your approach will fail. Because if you go by a greedy way, this is having a maximum count. Again, this represents indexes for this specific diff. So this is the maximum count. So one greedy way is I should go about and make all the other as a diff of 18, which will fail and it will give you an answer of 8. 8 operations are required. But then you say, okay, Aryan, I realize that minimum diff could give me the best answer. Whereas in like minimum diff is hard to achieve. So, minimum diff is easy to achieve and maximum diff is hard to achieve. So maybe these are giving a cost of 2, 2. So I will try, okay, make everyone as 11. Obviously, you will get a higher value of diff. Not exactly 8, but higher diff value. Okay, so you will realize that in this scenario, again, when I say this scenario, I mean this example itself. Why I put this example, you will realize because ultimately in the optimal answer, I will dry run with this example. So in this, you will realize that this will give you the maximum answer, which is 15. And there is no possible way to reach here by your greedy scenario. Now you realize, okay, your greedy failed. Now people might end up saying, okay, Aryan, I realized that, okay, 18 was given a value of 7. This might give a value of something. And I could see, okay, that it might reach to a mid value, something like that sort. You might think of that and you might think of applying a binary search here. Again, although in this problem, you can technically apply a binary search, but that is not yet intuitive. But still, in this scenario right now, with greedy with binary search, if you're trying to think of, see, this is the 15 as the answer. If you have to apply binary search, things should be sorted either like this, or again, when I say like this, I mean decreasing, or maybe decreasing like this fashion, or maybe like this fashion. It should be like this. But in this scenario, you will see that this is decreasing, then increasing, then decreasing. Okay, you can never reach a point which is minimum, which is diff. So you realize, okay, you cannot even apply a binary search on this diff. Okay, now what to do? Nothing we have to get back to our maqsad. We realize that we have to try for all the possible diffs. And for all the possible diff, give me the minimum. Okay, I will try to make all of them as equal to that specific diff. But we realize that would give me a complexity of O of n into k. Is it possible to get to a lesser complexity? Maybe, maybe not. But maqsad nahi bholna hai. Main aim is this only. Now, because we know greedy will not work now, we have to for sure apply this. Now, which means that I have to go and try for all the possible diffs. That is what the case was saying. Which means if I take this specific example itself, from this we had realized one observation that either, again, when I say I have to make it to all the specific diffs, which means, okay, I have to try for all the possible diffs, which means for a specific pair, I will try to make it equal to that specific diff which I want right now. So for every such operation, which means for every operation of making a diff to a specific number, there are three possible options. One option is no operation required, which means, as you can see, if I would have given you a task of making all the diffs as 4, then you can see easily in this pair, no operation required, diff is already 4. Okay, that is one thing. Or there could be a task where one operation is required, which means if the pair would have been something like, okay, I want to make the diff equal to 4. If the pair was something like this, let's say 2, 3. So I know if the pair is 2, 3, I can replace one element, and replacing one element, making it equal to any value. But now the diff has become equal to 4. So one operation. Now, worst to worst cases, I have to change both the elements and make them equal and make them some value so that the diff becomes equal to the required diff value. So by my previous observations, I required that either I could have 0 operations required on my pair, or 1 operation required on my pair, or 2 operations required on my pair. That's it. Which means that we have to maintain this, because ultimately that's what we want to do, no? Like we were saying that I will check for every diff value what is the corresponding count. What is the corresponding count? Which means for every diff value, I am trying to find, okay, how much cost I will incur if I make the entire array, as that specific diff. So I should be also knowing that how many elements are actually able to have 0 operation on that specific diff. And you might say, Aryan, still it is O of n into k, which you are trying to say. Yeah, it is. Hold on right now, but it is. So what we realize is that we will have to maintain for a specific diff, I have to maintain 0 operation count, 1 operation count, and 2 operation count, which will be required. Now, this 0 operation count isn't same as asking for how many. Again, I am trying to say for some specific diff, and I will try for all possible diffs, right? For some specific diff, isn't it, again, 0 operation, isn't it same as saying that how many such pairs are existing there who have this diff already? Yeah, this is. So I will have to maintain a current diff count, which means for this current diff, again, this diff is absolute value of nums of I and minus nums of n minus I minus 1. Cool. So I will simply maintain for that specific diff how many such counts are there already there. Now for this operation 1, okay, I don't know, but if ultimately I want to find how many operation 2 would be required for that specific diff, I can ultimately say n by 2 are the total number of pairs, 0 operation are required for these number of counts, 1 operation are required for these number of counts, then remaining will be operation 2 for sure required. So now my task says ultimately if I can find one operation, that how many such pairs are there whose, like, to achieve that specific diff, I need only one operation, then I'm good to say, and I will be able to get all the possible counts, which means, okay, 0 operation how much, 1 operation how much, 2 operation how much. But now your task or your maqsad changed to that how many pairs are having one operation required, that on doing one operation I will be able to achieve that specific diff. But again, if I have to ask for one operation on that specific diff, and one operation I will check for all the n by 2 pairs and for that specific diff, and diff I have k. So ultimately, again, the complexity will be O of n by 2 into k. How to optimize it? Hold on. So rather than going and checking for all the possible diffs, who will require one operation to be able to get to that specific diff, I will go in opposite direction. I will say, okay, what is the maximum possible diff achievable by that specific pair? Now, why I went to a maximum possible diff achievable by that specific pair is because if for any pair the maximum possible achievable diff is, let's say, something, now in this case you will see it is 4, so I know the maximum possible achievable diff is 4. If the maximum possible achievable diff is 4, I can never go beyond it because that's the maximum possible achievable diff. I can go less than it. Let's see by the example. So right now, if this was the pair, the current diff would have been 4 minus 2, which is 2, which I will maintain, and I will say that for these diff, which is the current diff right now, current diff, as you can see, current diff right now, for that specific diff, which is 2 right now, the count is 1. Okay, I have one such diff. Okay, but now my task was to get the maximum achievable diff for this pair. What is the maximum achievable diff considering I only change one element? Okay, you will say, Aryan, I have 2, 4. I want to achieve the maximum possible diff. So considering this is the minimum value, considering this is the maximum value, to achieve the maximum possible diff by changing only one, so I will do, okay, minimum I will change it to 0. So now maximum minus 0 was a value 4. So this is one option. Other option is you had a maximum, you had a minimum, so change this maximum to maximum k value k. So this is 6. So now the diff will be 6 minus 2, 4. So what I did was change the minimum to 0, change the maximum to k, and now found the new diff, which is here in this case it will be 4. All, like, luckily here also it is 4. Now this is by replacing one element. Here I replace the minimum element, here I replace the maximum element. Now I know I can only replace one element because I am applying for one operation, only one operation. So I realized the maximum achievable diff was maximum of 4 or 4. Now I realize the maximum achievable diff is 4. What this indicates? If it indicates that the max, if I have the number 2, 4, maximum achievable diff is 4, which means I am able to achieve a diff of 4, 3, 2, 1 and 0. How? If I change it to a 4, diff of 0 achievable. If I change it to 3, diff of 1 achievable. If I change it to, let's say, I want a diff of 2, right? If I change it to like 2 only, diff of 2 is achievable. If I change it to 1, diff of 3 is achievable. If I change it to 0, diff of 4 is achievable. But there is no possible scenario in which a diff of 5 or 6 will be achievable. That is the reason we have put in that this is the maximum possible diff which is achievable. You realized how this will help us? This will help us because now we will go on to every pair only once. For every pair, I will get his maximum possible achievable diff. And this maximum possible achievable diff will help me by saying, okay, if the maximum possible diff achievable is 4, which means 0, 1, 2, 3, 4, all are achievable, all are possible. So earlier, rather than trying for all the diffs, I will not go and try for all the diffs. For that specific pair, I will find the maximum achievable diff, and then I will go backwards up till 0 and I will mark, okay, this pair can give me this diff, this diff, this diff, this diff and this diff. That is how I can go in the backward direction, and thus I will be able to achieve my answer. So you realize I will maintain one operation as a hash map I could have maintained, but you will see I will maintain a vector. You will see in a minute why, but I will maintain for one operation. This is the maximum achievable diff. As you can see in this scenario, the maximum achievable diff was a 4, and I will increase its count by 1. Okay, this is the maximum achievable diff, which is possible. But you will realize you have to also navigate, or basically you have to also propagate the +1 +1 +1 to all of the values from 0 to 3. Now you know that it is a range update operation of +1. We have realized that either for range updates we can use a fen victory or a segment tree. If you have not watched the crash course, go and watch it. But in this scenario, I will not use it because I know already it has been already hard. I will simply use a prefix sum technique. Aryan, how? Bro, simple. If you have a if let's say you have built an array, that's the reason I told you, that's the reason I will use an array just to build it. And I will say, okay, for a value of 4, for a diff of 4, I'm able to achieve, let's say, 3. For maximum diff of 4, I was able to achieve 3 such counts. For diff of 3, I was able to achieve 2 counts. And for diff of 2, I was able to achieve, let's say, 1 count. For diff of 1, I was able to achieve, let's say, 4 count. So now I have to propagate this value 3 downwards to everyone. So technically what I should do? I should do a +3 here, +3 here, +3 here, and +3 here. Same way, I should propagate this 2 downwards. So I should do a +2 here, +2 here, +2 here. I should propagate a 1 downwards, +1 here, +1 here. Propagate a 4 downwards, so +4 here. What is this? This is simply by saying that just copy this. Okay, plus this. So this will become 2 + 3. Plus this, it will become a +2 + 3. I'm just pressing the previous value. Plus this, +1 +2 +3. Thus, I am able to achieve that. Again, plus this, 4 + 1 + 2 + 3. That is the reason I will use an array just to maintain the count. Right here, when I was making the count for a diff of 0 operation, thus here the hash map is sufficient. But because of I need to take a suffix summation here, that is the reason I will maintain an array here. An array will be of size k because I can have k possible diffs, because maximum possible diff itself is a k. And that is your answer. Now, I hope you guys got it, which means ultimately, quick recap, I will maintain a 0 operation count by simply current diff for that specific diff. 1 operation, how many such counts are there which will give 1 operation for that specific diff? I will maintain 1 operation for that specific diff. Again, this is the array which will give ultimately, again, after doing the suffix summation, this 1 operation for that specific, let's say 2. It says for a diff of 2, I have these many number of pairs which on 1 operation can give a diff of 2. Cool. So again, this is done 1 operation. Same way for 2 operation, remaining thing, which means n by 2 minus 1 operation minus 0 operation. A quick catch here that whenever you have to find for 2 operation, again, I might ask you, Aryan, how many 1 operations are required? You will see for a specific diff, let's say 2. Let's say 0 operation required, or basically existingly diff of 2 is occurring, let's say 4 times. And you are saying for a diff of 2, 1 operation, on doing 1 operation, you will be able to achieve 6 such pairs, which will give you a diff of 2 on 1 operation. Indirectly, in this 1 operation, you also have what? You also have this current diff covered already, which means that if I ask for 2 operation, your program was saying I can give you 5 pairs on which doing 1 operation will give you a diff of 2. So I will say, oh, I'll get a diff of 2 on these values having 1 operation, which means I should make sure I will have to basically remove this remove this count having that specific diff. What I mean by that is diff of 2 has already occurred 4 times. My operation says in the entire array, I will be able to achieve 6 such diff of 2s with 1 operation. So 4 are already covered, 6 he is covering. How many extra I require? I require 6 minus 4. So make sure 1 operation for that specific diff, do subtract your current diff count of that specific diff. No worries, it will be very clear with the dry run, but logically you should understand why. And ultimately getting your 1 operation minus 0 operation, that is done. So you will see 1 operation I have written as 1 operation diff minus current diff of 0. And that is for 2 operation. I know the cost 2 operation, this means okay, both the elements should change, so the cost is into 2. This is your final answer. Let's do a quick dry run. So this is the array which I have taken. Again, you can just take a snapshot, pause it, and just write it down. For diff of 18, 16, 15, 13, and 11, these are the corresponding index pairs which are giving that specific diff. That's by diff. Now I know firstly I have to maintain the current diff count. For this current diff of 18, as you can see, 1 minus 19, 19 minus 1, 18. So I have 4 such pairs. For 15, I have 3 such pairs. For 11, I have 1 such pair. For 13, I have 1 such pair. For 16, I have 1 such pair. Okay, this is done. This is saying current diff of count. But now my task was to achieve how many such diffs are there for that specific count, right? So this is the maximum achievable diff. So I went on and said, okay, 1 is here, 19 is here. How to achieve maximal achievable diff? How to get this value of maximum achievable diff? We realized backwards that we will firstly take the minimum value, we will take the maximum value. Maximum achievable diff, it can be maximum of this value or this value. What is this value? This value is maximum value minus 0. This value is minimum value minus k. So I realized that if I go back, my minimum element will be minimum out of both of them, maximum element will be maximum out of both of them. Maximum achievable diff will be maximum of either k minus minimum element or maximum element minus 0. So I've written the exact same thing. Maximum achievable diff will be maximum of k minus minimum element or maximum element minus 0. In this scenario, k minus minimum element, which means 20 minus 1 is 19, and maximum element minus 0, 19 minus 0 is 0. So maximum achievable diff is 19. And how many such are there? I have 1, 2, 3, 4, 1, 2, 3, 4. So I got a count of 4. You will say, Aryan, why 5? Okay, you will see. But right now it is 4. Same way here, 15, 0. Maximum achievable diff will be 15. Okay. Sorry, it will not 15. It will be changed to 20. Thus, maximum achievable diff is 20. So here the diff is 20. And how many such are there? I have 3 such there. Same way, next time for this thing, 16, 5, maximum achievable diff is changing this to 0. My diff will be 16. Count of 1. For this thing, maximum achievable diff will be 17. For this thing, maximum achievable diff will be 19. Thus, 19 achievable diff are 5. So I realized I have, for maximum achievable diff of 19, I have 5 such pairs. But this is saying only for the maximum. I want for all of them, which means how many such pairs are there for which one operation will give you that specific diff, which is 18, 19, 17, 20. So I realized that one operation for maximum achievable diff of 20 is 3, 19 is 5, 17 is 1, 16 is 1. So this is entirely array which I have pasted here. This represents for a diff of 20. For a diff of 20, I have 3 such pairs whose maximum achievable diff is 20 on one operation. So I want to get it for all such diffs. So I'll apply a suffix sum technique as I showed you above. So I'll do a suffix summation. So again, just expand this entire array. So it will be 0 to 20. K is 20. So I will make an array size of k plus 1. So here it will say 3. Then plus 5, it becomes 8. Then again, you will see, keep on copying 8, and then you will get plus 1, 9. Again, keep on copying 9 until you get 16. As you can see, 16, 10, 10, 10, 10, 10, 10, 10, 10, and so on and so forth. It will keep on going. What this indicates now? This indicates for a achievable diff of, again, now maximum is gone. Now this is the final array. For an achievable diff of 16, I have 10 such pairs which will require at max one operation, right? Because you will see in this array while we were building, we simply told for a diff of 19, I have 5 such pairs whose maximum achievable diff is achievable diff is 19, which means 18, 16, 17, 14, 15, like this. All of them will also be able to achieve a diff of that specific value, which means 17, 18, 19. Like these are diff values. 5 such pairs are there whose diff I can achieve to that specific values which is required for me 19, 17, 18, 19 by just doing one operation. But in that ultimately the one having 0 operation was also counted because I was going down, 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 as you can remember from this example itself. If I will make it a maximum achievable diff of let's say 6, I found out. So I was saying the diff of 0, 1, 2, 3, 4 all are achievable, and I have one such pair. I have one such pair. On doing one operation, I will be able to achieve my diff of 4, 3, 2, 1. But I realized a diff of 2 was already there. So a diff of 2 technically required no operation, but I was still saying that maximum achievable diff 4, I was able to achieve that maximum diff in one operation, so I can achieve 3, 2, 1, 0 also. Technically 0, this value 2 I will never be able to obtain, right? So this is one case because of which I told you that you have to handle it separately, that while doing one operation make sure to subtract your current diff count, because that is something you will not be able to handle by you will not be able to handle by just one operation. Cool? Because see, if the diff is 2, you technically handle by you can handle that by one operation by saying, okay, I remove this to 6. But you can think of it as vice versa. Okay, you can handle it, or you can just simply say, okay, even if not, I will still be able to achieve that value. So it is not that, okay, you will not be able to handle it ever. You will be able to handle it. It is that it is already handled. So both the scenarios are covered if you will just subtract the operation here, which is already handled. So this thing already handled. So just subtract this. Or you can also think of that, okay, I have already handled it and it will not be required to handle here. So also subtract here. So now we realize that, okay, this thing is already handled. So we don't have to handle it, which means now ultimately let's go on and try to get for all the diffs what is the minimum possible answer. Operations for this specific diff 18, I realized minimum operation will be obviously that I know for 18 I have 4 such pairs. मकसद नहीं बोलना है, your n was 20, so you have to make 10 pairs. 4 such pairs are already having a diff of 18, right? For diff of 18, on doing one operation, how many such pairs I will be able to achieve? I will go to 18 and will ask, I was able to achieve 8 pairs, on which if I do one operation, I will be able to achieve a diff of 18. So 4 already done. How many are remaining? This 8 represents 18 diff, 8 pairs. 4 are already done. 4 already done. So subtract a 4. I am remaining with 4 now. Now this is on these 4 I will apply one operation, which means I will change one value. On the remaining, which means 10 minus 4 minus 4, which means 10 minus 8. I will have to apply 2 operations, which means I have to multiply that by 2. Operations equal to 2, which means both values should be changed. That is a 4 here. 2 into 2, 4 plus, which is 8. Same way, if I ask you, okay, change every diff to 15. I know maksad is 10 values, 10 pairs. I have 3 pairs already which have the diff of 15. I'll go to 15. I was able to achieve 10 such pairs having a diff of 15. 3 are already done. How many are remaining where I will apply operation of 1? I will have 7. I will simply apply 7. 7 operation I will apply. Remaining will be 0. Thus operation required will be 7. And that is the reason the answer was 7. Again, you can try for the remaining by yourself. You will see it is the maximum value. Thus, this is a dry run for your actual example. Now let's see the code. It's exactly same. So what we realized that ultimately I will firstly get an order map of count of current diff count. For the current diff, what is the count? And this is one operation. This argument will be maximum achievable diff. So I will go on to all the pairs, which means all the only half values. I'll find the current diff. I'll update my current diff count and do a plus plus. I'll find the minimum value, maximum value, find the maximum achievable diff by k minus minimum element and maximum element minus 0. Then I'll say, okay, one operation on that maximum achievable diff plus plus. I know that this is maximum achievable diff, but I have, okay, maximum achievable diff is, let's say, 18. So still 17, 16, 14, 15, everyone is possible now. So I will do a suffix summation. Maximum achievable diff is, let's say, k minus 1. Again, why this is? Because I have to go and look for k. I have to go and look for maximum achievable diff plus 1. Plus 1. So as you can see, this plus 1. It is a reason. I'm just simply doing asking for a plus 1, plus 1. The same way I showed you here. Where it is gone, yeah, plus 1, plus 1. I'm just asking for a plus 1 value and adding it to myself entirely. So I'm asking for a plus 1 value and adding to myself entirely. Then now when this entire thing is built, simply go on to all the possible diffs and their corresponding count. Again, this count represents existing count where no operation, existing count where no operation is required. So I will ask for, okay, how many such pairs are there for which one extra operation will be required? I will go and ask, okay, one operation on that specific diff, how many such pairs were there? And I was already able to cover these count number of pairs already. So this is extra number of pairs where one operation will be required. Now remaining will be 2. Remaining will be n by 2 minus 1 extra minus your count, which is your 0 operations required. Thus for these TWO, I will require 2 operations. So ultimately your answer will be 1 extra into 1, 2 into 2. And this is your answer ultimately. Again, minimize your answer for all the possible diffs, and that's your answer. Cool. Again, the time will be O of n plus k, or you can say only k, because k is less than, no, it is not less than. Okay, answer is O of n plus k, because this will take O of n time and this will take O of k time. Cool. And this will again take O of n time, or you can say O of k time. Both are equal. Minimum of O of n into k, but yeah, O of n plus k will be the complexity. Space will be O of n because of you are using k and you are using diff, so you can say the space is also O of n plus k. Cool. I hope you guys got it. If yes, again, this is not that easy even to think of, or if you have been thinking, okay, you must have realized it is not that easy. Cool. Bye bye. Take care, and please do join on or do connect on Twitter. Bye bye.